Okay, so we're starting Module 10. We're going to start with 10.1, comparing two proportions. So this module is going to be really similar to what we did in Module 9, except for now instead of having a one proportion sample, we're going to have a two proportion sample. So suppose we want to compare the proportions of individuals with a certain characteristic in population 1 and population 2. We can call the parameters of interest P sub 1 and P sub 2. The ideal strategy is to take a separate random sample from each population to compare the sample proportions with that characteristic. So what if we wanted to compare the effectiveness of treatment 1 and treatment 2 in a completely randomized experiment? This time the parameter P sub 1 and P sub 2 that we want to compare are the true proportions of successful outcomes for each treatment. We use the proportions of successes in the two treatment groups to make the comparison. So here's a table that summarizes the two situations. So we saw in Module 7, the sampling distribution of a sample proportion has the following properties. The center is going to be the mu, in this case would just be the p, the population proportion, and your spread, sigma sub p hat, would be the square root of p times 1 minus p over n. So if the sample is no more than 10% of the population. And it's going to be normal if you take n times p and n times 1 minus p and you get something at least 10. So to explore the sampling distribution of the difference between these two proportions, let's start with the two populations having a known proportion of successes. So let's say at school 1, 70% of students did their homework last night, and at school 2, 50% of students did their homework. Suppose the counselor at school 1 takes a simple random sample of 100 students and records the sample proportion that did their homework. And at school 2, the counselor takes a random sample too of 200 students and records the same sample proportion that did their homework. What can we say about the difference p hat sub 1 minus p hat sub 2 in the sample proportions? Okay, so using software here, there's a generated simple random sample of 100 students from school 1 and 200 students from school 2. The difference in the sample proportions was then calculated and plotted, and we repeated this process 1,000 times, so using the software, and here are the results shown. So what do you notice about their centers? Well, in this case, all you had to do was take 0.70 minus 0.5 to get the 0.2. Is that true for the spreads? It is not. So think back when you had to find the new standard deviations, what you had to do. Okay. And then what do you notice about the shape? Okay, if the other two are normal, then it's also normal. So whenever you have, just to find the mu's, again, you can take the difference of those. But when you're dealing with standard deviations, you're going to have to take the sum of the variances. So we learned that back in Module 6. So here we can find the mu. That's what we saw. And here, if I want to find what's going on for the standard deviations, then I have to take the standard deviation square plus, remember it's always a plus in standard deviations, the standard deviation squared. So the squares get rid of the square roots there, so you're left with this. But again, that's still the variance squared. So after you take the square root, here is your new variance that you will be using. And these are on your formula sheet. Okay, so just in summary, you can read through. That's exactly what we just talked about. So don't forget, for the shape, you're going to have to make sure that the sampling distribution is approximately normal. So when you take all of the normalities, you're going to have to do it 4 times now. Okay, so you're going to have to take n times p and n times 1 minus p for your first sample, and n times p and n times 1 minus p for your second sample. So you're going to have to do it 4 times. And all of those have to be at least 10. So for the center, that's the easy part. You can just take the difference. And for the spread, that's the formula we just talked about, but you have to check the 10% rule for that. I don't know why the writing is carrying over. Smart's doing something funky. All right. So here's just, again, a summary of everything for you with a nice visual. Okay, so the sampling distribution of differences between two proportions. Make sure, again, you check all 4, independent, random, all of those. You're going to have to check conditions before you can do a test, okay, or a confidence interval, just like we have learned before. So let's do our first example. Who does more homework? Suppose there are 2 large high schools, each with more than 2,000 students in a certain town. At school 1, 70% of students did their homework last night. Only 50% of the students at school 2 did their homework last night. The counselor at school 1 takes a simple random sample of 100 students and records the proportion that did homework. School 2's counselor takes a simple random sample of 200 students and records the proportion that did homework. School 1's counselor and School 2's counselor meet to discuss the results of the homework surveys. After the meeting, they both report to their principals that, hey, P sub 1 hat minus P sub 2 hat is 0.10. So we're going to describe the shape, the center, and the spread of the sampling distribution for that P sub 1 hat minus P sub 2 hat. So let's take n times p. So our n for our first sample was 100 students, and we saw that 70% did their homework, so we got 70 successes. And then n times 1 minus p, we got 30 failures. So at school 2, there were 200 times 0.5, which was 100, and 200 again times the failure proportion is 100. So we had 100 successes and 100 failures. Since all of those are at least 10, then we can say that the sampling distribution is approximately normal. We know the mean difference is 0.70 minus 0.50, which is 0.2. And we can find the standard deviation by taking the square root of p times 1 minus p over 100 in the first case, and your p times 1 minus p over 200 for the second sample here. And when you add those and take the square root, you get 0.058. Okay, so here's a nice density curve of what you're finding. So here we can put our 0.2 in the middle of our density curve. So let's do with standard deviations, 0.2 minus 0.058 and 0.2 plus 0.058 to go 1 standard deviation away. And don't forget that's at the point of inflection. Okay. And then 2 standard deviations away, we can put it here. So subtract another 0.058 and add another 0.508 and go ahead and do 3 standard deviations. So you get your normal density curve looking something like this. And the counselor said that it was going to be 0.1. So find the probability of getting a difference in the sample proportions of excuse me, a 0.1 or less from the 2 surveys. And then does the result in part B give us reason to doubt the counselor's reported value? So if you'd like to compute it to z-scores, you can, and then use the table, or you could do the normal CDF. Let me write down what that would be for you really quick. From negative infinity until 0.10, if the mean is 0.2 and the standard deviation was 0.058, so you could also do that. Again, if you're using normal CDF, you either have to draw the density curve or describe every single part in that normal CDF of what you're doing. So does the result in part B give us reason to doubt the counselor's reported value? Yes. Okay, so there's only about a 4% chance of getting a difference in the sample proportion as small or smaller than 0.10 reported by the counselor. So I think that they're fibbing to their principals. Okay, so if you wanted to put all this in your calculator without even doing the normal CDF, you can. You can go to the second proportion z-test here. So stat over to test, and you can go and scroll down. So to proportion z-test, it's number 6, and put in all your information. So this is from your first sample, this would be from your second sample, and that was from up here. This is something new now. Here, and you could try it for the counselor situation as well. Okay. Make sure you set up your hypothesis. So in this case, we're looking for greater. In the counselor situation, we were looking for something smaller, so it'd be less than. And then hit calculate. And this p-value was really big, so we could fail to reject. Okay. If you wanted the, this was the output screen, or if you hit draw, you would get something that looked like that. Why don't you try that for the counselor one and see how you did? All right. With confidence intervals for P1 minus P sub 2. So now instead of doing the hypothesis, you could also do a confidence interval. So you're going to take your statistic plus or minus your critical value times the standard deviation of the statistic. Well, we know the standard deviation, checking that 10% rule, right? And if we don't know all the parameters for P1 and P2, we can use the standard deviation with the sample proportions. This is going to be the standard error when you're using the sample proportions. The normal condition, when it's met, we can find the critical value for Z star. We have our formula sheet to find that. So we could set it up. Our statistic would be the P sub 1 minus P sub 2 hat, plus or minus our Z star, times our standard error there. Okay, so here it is summarized, and in order to use this, you'd have to check your conditions, random, normal, and independent. And since you have 2 things going on, you're going to have to check 4 different calculations for normal. And if you're sampling without replacement, then you're going to definitely have to do the 10% condition for independent. All right, so teens and adults on social networks. As part of the Pew Internet and American Life project, researchers conducted 2 surveys in late 2009. The first survey asked a random sample of 800 U.S. teens about their use of social media and the internet. A second survey posed similar questions to a random sample of 2,253 U.S. adults. In these 2 studies, 73% of teens and 47% of adults said that they use social networking sites. Use these results to construct and interpret a 95% confidence interval for the difference between the proportions of all U.S. teens and adults who use social networking sites. Okay, so make sure you're telling me what you're trying to find here, the test you're going to use. So P sub 1 we're going to say is the proportion of all U.S. teens who use a social networking site, and P sub 2 is the proportion of all U.S. adults. And we want to estimate that difference, P sub 1 minus P sub 2, at the 95% confidence interval. So the test that we're going to have to use is a 2-sample Z interval for P sub 1 minus P sub 2. Now we're going to have to check our conditions. Random, it said that they came from random samples. Normal, check your n times p and n times 1 minus p for both samples, and all of those are at least 10. Independent, 1 is of teens and 1 is of adults, so these are definitely independent. Okay, but since the researchers are sampling without replacement, let's also check the 10% condition. So 10 times our population of 800 here is 8,000, or sorry, 10 times our sample of 800 is 8,000. So I would say that there's at least 8,000 teens, and our sample was of 2,253 adults, so 10 times that is 22,530 adults. And again, yes, we clearly have more than that in the US. So now we're going to construct our interval. So we can do our p sub 1 hat minus p sub 2 hat. 95% would give us a z-score of 1.96. And our standard error here is 0.73 times 0.2 over 800 plus 0.47 times 0.45 over 2,253, all square rooted, and simplify that down. And there is your confidence interval. So we are 95% confident that the interval from 0.223 to 0.297 captures the true difference in the proportion of all US teens and adults who use social networking sites. Okay. If you wanted to do this in your calculator, you could go to Stats, Test, do a 2 proportion Z interval, put in your X1 and your N1, your X2, your N2, your confidence level would be 0.95, hit Calculate, and there's your interval. So I would definitely check with that. Okay, you guys try this one. And go ahead and pause, and when you're ready to check yourself, move on. And here's the answer, and let me know if you need any help. So if I wanted to do a significance test, remember that the null is always no difference. So whenever we're doing the p sub 1 minus p sub 2, we're going to say that it's going to equal 0. So it's no difference. Another way you can write that is that p sub 1 just equals p sub 2. Okay? And then in the alternative, you're either going to have a greater than, a less than, or a not equal to. All right, to do a significance test, if you'd like to find the z-score, you definitely can. But you can also do these in your calculator. We're never going to use the pooled, okay, when we put it in the calculator. If you'd like to learn more about pooled, you can. I'm going to go ahead and go through this, though. Okay. So we're going to check random, normal, independent. Do I sound like a broken record with that? I think I do. I'm sorry, I'm a little sick, so my voice isn't the best. All right, so here if you'd like to do the Z and you can kind of set all this up here with your Z-scores, then that's great. You can also do this, like I said, in your calculator, but let's see how we do. Let's go to this example of hungry children. Okay, so researchers designed a survey to compare the proportions of children who come to school without eating breakfast in 2 low-income elementary schools. A simple random sample of 80 students from School 1 found that 19 had not eaten breakfast. At School 2, 150 students in the sample had 26 who had not eaten breakfast. Okay, so more than 1,500 students attend each school. Do these data give convincing evidence of a difference in the population proportions? So I want you to carry out a significance test. So first, see if you can write your hypothesis. And make sure you label what all of your variables mean unless you write your hypothesis in words. Okay, so here my hypothesis is that P1 minus P sub 2, there's no difference, is that it's 0. And then this one just wants to know, is there a difference? So a difference would just be not equals. And everything else stays the same. And since I wrote with variables, I need to state what P sub 1 and P sub 2 are. Okay. Now we're going to do a 2-sample z-test for P sub 1 minus P sub 2. But first we got to check our conditions. It said that both of those were random samples. Normal, you're going to have to check at 4 different calculations, and all of those are at least 10. And independent, let's check our 10% condition. And we have at least 1,500 students at School 2 and at least 800 students at School 1 because they told us that there was at least 1,500, so we're good to go there. And the samples are independent because each schools are different, so you're checking from 2 different schools. All right, so if you wanted to do the z-score, you can. Since it's not equal to, make sure that you multiply it by 2 if you're going to do all of it out by hand to get to your p-value. And then you can have your conclusion, which I'm going to go back to here in a second. In the calculator, you could do a 2 proportion z-test, and this is how I'm always going to do it. It's just quick and fast and get the same results. So here in the calculator, I found my p to be 0.2426688 approximately, and I got my z-score. So instead of having to do all of that work, it was quick and easy and fast, which is nice when you're on a time crunch. So since our p-value was approximately 0.24, that's greater than the alpha because we're at 95% confidence, so our alpha is 0.05. So this is not statistically significant, and we failed to reject the null hypothesis. So there's not sufficient evidence to conclude that the school proportions of students who didn't eat breakfast are different. Okay? All right, you guys try this one. And you can either do it out by hand with the z-scores or in your calculator. I'm fine either way. And when you're ready to move on, just hit on pause. So here's my hypothesis. The test I'm going to use. Check the conditions. And then I'm actually going to use the calculator, but here, if you like it all out by hand, just showing it. And in the calculator, you should get a similar p-value. It's a more accurate p-value, actually. And here our p-value is statistically significant because it is smaller than your alpha, so we can reject the null and conclude that there is convincing evidence of a lower heart attack rate for middle-aged men who, like these, take this gemfibrozil than those who only take a placebo. I don't think I just said that right. Okay, so again, you can always put everything in your calculator. Just clearly label everything and explain in non-calculator speak what you are doing. So here is a summary, and hopefully you guys are solid on this because all you're doing now is 2 proportions, first the 1, and in section 2.2 we're going to be doing 2 means instead of 1. So you should rock this, this test. And again, just everything we've talked about. All right, so we'll start 10.2 next.